Hey everyone, this is section 2.5, Linear Inequalities. These are inequalities as opposed to equations, so instead of something like x equals 5, we have x less than 5, or an equation with the greater than or equal to in it. So the good news is solving these inequalities is going to be exactly the same as solving equations, except when you multiply or divide both sides by a negative number, you must flip the inequality. What I mean by that is take a look at our inequality down here, 2 is less than 5. That is true, and if we multiply both sides by, let's say, positive 2, we would get 4 is less than 10, which is also true. But let's say we multiply both sides by a negative number, like negative 3. Well then, what do we get? Negative 3 times negative 2 is negative 6, and negative 3 times 5 is negative 15. But notice it's no longer true that negative 6 is less than negative 15. That equation is actually false, or that inequality is false, so we'd actually have to flip it to make it true. So because of this fact, because when you multiply or even divide both sides by a negative number, the inequality is only true if you remember to flip the inequality. Also, as you're doing your algebra, if you have to multiply or divide by a negative, you have to flip the inequality. So we'll see an example of that right now. First, we're going to talk about how to write our answer in different ways. Obviously, you can solve the inequality just like an equation and get your answer as an inequality. So maybe your answer is x greater than or equal to 2. First, we need to know how to put that on a number line because we're representing a set of numbers, all the numbers that are equal to 2 or bigger. So on the number line, since it's greater than or equal to, we're going to start with brackets on the 2. If it was just greater than, we would do parentheses there, and we'll see an example of that in a sec. So we put brackets on the 2, and it's opening to the right because all the numbers greater than 2 are all going to be over here. That's what the graph on a number line means, or what it looks like. It just shows visually all the numbers at 2 and bigger, and the brackets tell us that we're including 2. That's because it's greater than or equal to. Interval notation is kind of just taking that little shaded area and summing it up in two numbers. This shaded area goes from 2 all the way off to infinity. So those are the two numbers we're going to use, 2 and infinity. And then since we have brackets on our 2, we're going to put brackets on our 2. Right? That just means that we're including 2 in our answer. And infinity isn't a number, so you can never include it. Always use parentheses on infinity. So now, so far we have three things meaning the same thing. X is greater than or equal to 2. All the numbers from 2 are larger. All the numbers from 2 to infinity. Right? It all means the same thing, just different ways to write it. Lastly, set builder notation. This one's like the least common, just so you know. And it's also kind of silly because it's basically just your inequality. But let me kind of walk you through what this says. So this is set notation with these braces. So it says the set of all x's such that, that's how we read this vertical line, such that, and then you just enter your inequality, which was x greater than or equal to 2. Okay, so we would just read this as the set of all x's such that x is greater than or equal to 2. Again, these all mean the same thing. They're just four different ways to write it. Let's try one more of those. We have our inequality, y is less than negative 3. Let's graph it on a number line first. So I have set up a number line with negative 3 over there. Less than means we're just going to do parentheses, not brackets. But we're going to do it at the negative 3. Try that one more time. And less than would be to the left of negative 3. So we're going to shade all the values that are less than negative 3. And put a little arrow there. Okay? So that graph on the number line represents all the values less than negative 3, not including negative 3 itself. For interval notation, remember we're just summing this up in two numbers. This is from, we always go left to right, so this is from negative infinity all the way up to negative 3. So those are our numbers, negative infinity and negative 3. And then you always put parentheses on infinity, and negative 3 also has parentheses for the same reason that it does in the graph, because it's less than. If it was less than or equal to, then we'd use a bracket on the negative 3. Alright, and for our set builder notation, this is the set of all y's such that y is less than negative 3. Right, so obviously since we have y's, you put a y in the first one. Just tell us it's a set of y values, whatever y is representing. Okay, so those are the four different ways you can write your answer. That's kind of the end of once you solve an inequality. So let's actually solve an inequality here. Here we want to solve it for t, and we have negative 5t is less than or equal to negative 15. The less than or equal to we're going to treat like our equals. So if this is an equation and we wanted to get t by itself, we would have to divide both sides by negative 5. Right, we're at step 3 in solving equations because all of our t's are on one side, all the numbers on the other. We just need to actually solve, get rid of that number in front, so we divide. Now notice real quick, well first our negative 5's cancel out. We just divided both sides by a negative number, and I told you the exception is, the thing that makes this different than equations is that now we actually have to flip this inequality. So pay attention here. This becomes greater than or equal to. Right? Anytime you multiply or divide a negative number on both sides of the inequality, you have to flip it. Negative 15 over negative 5 is 3, so we get the answer of the inequality. T is greater than or equal to 3. That's our answer as an inequality, but remember we can write it different ways. On a number line, let me just throw this up real quick. Here's 0, here's 3. We want all the t's greater than or equal to, so brackets at 3, and all the greater values are over here to the right. There we go, there's the graph on a number line. As an interval, this is going from 3 to infinity, so 3 comma infinity, always parentheses on infinity, brackets on the 3. And then set builder notation, it's the set of all t's such that t is greater than or equal to 3. There's the 4 different ways we can write our answer. Let's do another one. This one's a little bit more complicated. You really need to remember your steps for solving linear equations. So step 1 is clear parentheses and combine like terms. We're going to distribute here. So I'll write everything else. 4x greater than, this will be negative 21 plus a positive 6x. Don't forget negative 3 times negative 2 there. And a plus 1. Still step 1 because we can combine these like terms. A negative 21 plus 1. So we have 4x greater than. Negative 21 plus 1 will be negative 20. And we still have our plus 6x. Now we need to get all our x's to one side. So I'm going to do a minus 6x and a minus 6x. Those cancel, and over here I get a negative 2x greater than negative 20. And then I need to divide by a negative 2. Notice again I divided by a negative. This doesn't happen every time you solve an equation. This just happened to happen here in the last one. But we divided by a negative, so I have x, this flips, less than. And this becomes a positive 10. Okay? So again, I had to get x by itself by dividing by a negative 2. So I had to flip the inequality. Oops. So real quick, I'm just going to move all that up. Real quick, let's write our answer different ways. We have number line first. All the x's less than 10. Less than is just parentheses, and we're shading to the left. There we go. This graph is going from negative infinity up to 10. So those are our numbers. Negative infinity to 10. Parentheses on both. And then set builder notation, the set of all x's such that x is less than 10. Alright, one last inequality here is a word problem. Find all values for x so that the perimeter of the rectangle is less than 50 feet. So we have a rectangle here. One side is x, the other is x plus 5. It's talking about perimeter, and wants the perimeter to be less than 50 feet. Notice we're going to have a less than in there somewhere. Now for perimeter is pretty easy, right? They're telling us that our sides are x and x plus 5. That means this one up here is x plus 5, right? And this one here is also x. So when we add up all our sides, we're going to have x plus x plus x plus 5 plus x plus 5. That's our perimeter. That's all of our values added together. And we want this to be less than 50 feet. So that's the inequality. Perimeter is just adding up all the sides, set it less than 50. Now what's going to happen on our left-hand side? Well, we have x, 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 and x. There's 1, 2, 3, 4 x's, so we're going to call that 4x. That's combining like terms right there. 5 plus 5 is 10, so we have 4x plus 5, 4x plus 10 is less than 50. Let's see if we can move this. Good. Okay, and then you're going to subtract 10 from both sides, trying to get all of our x's on one side, all our numbers on the other. Less than 40. Then you divide both sides by 4, and this will give you x less than 10, and these, it said it was in feet, I think, so 10 feet. Okay, so it's just saying if one of the sides is less than 10, that means the other side would be less than 15, by the way. If x is less than 10, then your perimeter, the distance around, will be less than 50. So there you go. That's 2.5. That's chapter 2. I hope this worked out for you pretty well. Let me know if you have any questions, and keep up the good work.